You're watching Skywatch Media News, and here's what's happening for the final week of March 2019. If you were to explain what's happening on the surface of the sun in recent months, you would probably say that we have entered into a long period of solar minimum, a quiet time in which there are very few, if any, observable sunspots. That would certainly be the consensus from solar scientists who monitor the sun's activity. That is, until recently. Something is happening on the sun's surface that can only be considered as a rarity in a time of solar minimum. Sunspots are not only appearing on the surface, but they are crackling with C-class solar flares within the sun's magnetic field. Just a few days ago, the sunspot called AR 2736 didn't exist. But now the rapidly growing region stretches for more than 100,000 kilometers, or more than 62,000 miles across the solar surface. Sunspots are known as floating islands of magnetism, with a positive north and a negative south pole. But sunspot 2736 is very different. It has multiple poles that are interacting with one another while crackling with flares. Thus, magnetic lines of opposing polarity that are moving in opposite directions while exploding with cosmic energy in the process. When explaining space weather, it's important to know that C-class solar flares do not constitute a major solar event. However, the explosions that are presently occurring are noteworthy because for most of the year, the sun has been very quiet, entering into a solar minimum. Therefore, the C-flares are a legitimate uptick in solar activity for this cycle, as they interact with the Earth's atmosphere, disrupt communications on Earth, and eject CMEs towards our planet. On March 20th, the new sunspot exploded, producing a C4 class flare. The explosion sent minor waves of ionization rippling through the Earth's upper atmosphere and caused a shortwave radio brownout over southern parts of Europe and all of Africa. The explosion also hurled a coronal mass ejection into space where it hit the Earth's atmosphere on March the 23rd, creating intense northern lights as far south as Indiana. So what happened to the approaching solar storm which forecasters had warned would directly hit Earth? Based on speed forecasting of the CME by the Solar and Heliospheric Observatory, it was estimated to arrive on the afternoon of March 23rd. Models revealed the shape and the evolution of the coronal mass ejection as it expanded out into space, indicating that it would be a direct hit on the Earth. A direct hit of this magnitude on the Earth's magnetic field would initiate intense geomagnetic activity, producing intense auroral displays. News spread online and across media outlets that a big geomagnetic storm was about to hit the planet that would light up the sky over New York City and Chicago. But as it turned out, March 23rd came and went with no sign of the CME. Geomagnetic activity was registering near zero, and the spectacle did not materialize as originally forecast. On March 24th, which would be the following day of its forecast arrival time, the instruments on board of the NASA Discover satellite began to register the arrival of the CME. But even after its arrival, nothing spectacular seemed to happen. No auroras and no communication disruptions. For some unknown reason, the CME slowed just enough during its journey towards Earth that it produced only a minimal effect on our planet. Space weather forecasting is not always accurate and requires precise analysis in order to better inform the public regarding incoming geomagnetic storms and the severity of its impact. The Solar Dynamics Observatory can capture solar flares, and it can show us a coronal mass ejection just as it is leaving the sun's surface. Additionally, the Solar and Heliospheric Observatory can take images that show us how that CME is moving through space around the sun and giving us an estimate of its initial density and speed. Afterwards, it will take about 3 days to get further information because it normally takes that long for the CME to reach the Discover satellite that is located directly in front of the sun, some 1 million miles from the Earth. If the computer models are off, even by a small percentage, by the time the CME arrives on Earth, the model results could differ significantly from the final results. The errors in space weather forecasting is a serious matter that needs to be addressed as quickly as possible, regardless of the severity of the event. This requires investing more in space weather research, developing new and improved modeling techniques, and properly recruiting and training more forecasters. This would all be beneficial. But the lack of updated data on incoming CMEs is the biggest concern and the one with the utmost priority. Space weather forecasters are lacking the proper data because once the coronal mass ejection leaves the view that is seen by SOHO, it becomes invisible here on Earth until it reaches the strategically placed satellites that provide the update on the speed and the strength of the storm. In order to accurately forecast information back to Earth, more satellites and spacecraft must be launched into the inner solar system, positioned between the sun and the Earth to provide continual updates on solar wind and the motion of CMEs as they expand away from the sun. Until such time as improvements are implemented, we can only make do with what is presently available, which may not be sufficient enough to protect us from intense solar storms that are Earth-directed. So when it is announced that there is the potential for a solar storm with intense auroras, regardless of how far and wide it is being reported by the media or how certain the timing seems, you, the viewers, should always inject that uncertainty into what's being said and then plan accordingly. The behavior of our sun is unpredictable. Although we are in the midst of a solar minimum, the surface of the sun is still producing sunspots and CMEs. Trying to predict what will happen next on the sun's surface is like trying to thread a needle. It's more complicated than it seems. The effects of solar activity are being felt far and wide, across the atmosphere and on our planet's surface. Shortly after midnight on March 26th, a rare earthquake struck North Carolina near the city of Archdale. According to witnesses, the earthquake produced a long, booming sound strong enough to shake homes.
Randall County 911.
There was a loud boom and the house shook. It almost sounded like an appliance fell over or something. I don't know, but it's freaking me out because I'm here by myself.
We didn't hear a large explosion or anything, but something just literally shook my whole entire house. It was just a really loud explosion, and it shook my house.
Looking on Facebook, and people said it was an earthquake.
Yes, we've received reports of that as well, ma'am.
Earthquakes are rare in this part of North Carolina, but they do occur occasionally, and so far the magnitude of the most recent tremor has been relatively small. The more frequent earthquakes that do occur are typically centered in and near mountainous regions of the state. Although witnesses reported that their homes were shaking, earthquakes similar to the recent one near Archdale, which registered 2.6, are usually not strong enough to produce any noticeable damage. So why did this earthquake shake like thunder or sound like an explosion, according to eyewitnesses? An epicenter that is more shallow has the tendency to release more energy on the Earth's surface. Because noise can travel further from an epicenter than the shaking itself, it allows people to hear the sounds of the event, in comparison to deeper earthquakes, where the actual effects of the event are distributed over a much wider area. As with any earthquake, small or large, the best policy is to always be certain that no damage has occurred to your home or property. Typically, earthquakes weaker than 2.5 do not cause any damage, and shaking may not be felt, but they can cause widespread booms and rumblings. These thunderous sounds will startle residents, and it will create a flurry of statements on social media wishing to share what they heard and felt. A genuine expression of concern, asking questions and reaching out for answers that may unlock the mystery of these mysterious events. So buckle up, folks. We are in for a very long and bumpy ride. As you look to the sky and behold the magnificence of the sun, know that it stands alone to move the planets by the virtue of its power, to provide light and warmth to our planet, which is not worthy of its dignity, but granted as a gift to us by the grace of the Creator of all life in the universe. Thanks for watching.